So, doing a different rotation than 90, 180, 270. All right, a little bit different. If you could see, the first polygon I gave you was a regular pentagon penta. Got that, Andrew? Pentagon penta. Okay, good talk. 5 congruent triangles. And now I'm asking you to rotate 72 degrees, starting at point E around point X, 72 degrees. Well, I'm certainly not going to turn my paper 72 degrees, right? That's going to be a little tough. So how can I figure out how that 72 is going to help me? Well, these are all 5 congruent triangles, right? Which means what about these angles here? They're all congruent. And if I add them all up, I'm going to have 360 degrees. So can you find how much one angle would be? If I want to go from here to here, or if I want to go from here to here, I would take 360 and divide it by 5. And hey, what ends up coming up? 72 degrees. So every time you rotate around point X from vertex to vertex, you're going 72 degrees. That makes my problem a little easier now. Because if I'm at point E and I want to go 72 degrees, in what direction? Counterclockwise. Oh, that just means I go to the next vertex when I rotate through an angle of 72 in this pentagon, which would bring me to what vertex here? 20? Point P. Yep. So point P is the image of E after I rotate it 72 degrees. All right, well, what if it's not 72? Now it's 216. Is that going to make my life tougher? No. Here you go. Ready? So we're starting from point P now. Counterclockwise, 216. Everyone ready? 72 degrees to get to A. How many degrees to get to T? 144. Okay, what about to get to N? 216. It's a multiple of 72. All right, so I end up at point N. All right. Hey, regular octagon, 8's up. Never mind. Now we're going 8 congruent triangles. 8 congruent triangles. Quickly find the angle I rotate through one vertex to another. Every time I rotate vertex to vertex, I'm going to rotate 18. How many degrees? It is 45 degrees every time I go vertex to vertex. 360 divided by 8. All right, let's go around the room here, answer some questions. Rotate 45 degrees for point G, about Z, which is the center. So G goes to where after I rotate 45 degrees? Here you go in 10. That is point I. Ooh, 225 now, 225. From point U. Point U, 225 degrees. 8 when you're ready. Where do I end up? Point I again. Yep. Woo. Questions going too fast? Okay, 315 now. 315 degrees around point Z, starting at E now. 315. Where do we end up? 15? Oh, look at that. Are we doing something wrong? Nope. Oh, can we rotate a segment? Yeah, we can rotate a segment. And if you're getting a little worried about rotating a segment, take each endpoint separately. Rotate point E, and then rotate point I. Let me know where you end up. Or some of you can just handle the segment as a whole. Go right ahead, 270 degrees, EI. And no, it does not end up at point I. Ends up at 10. Segment GH or HG, whatever you're feeling. 135 degree rotation of S. Now of S. What do you got for me? 20? point G, and I am hoping nobody is touching their calculators now. Nobody should be touching their calculators. And it worries me if you don't know why. 360-degree rotation of ST. Ooh, 9, where do I end up? Thank you. Everyone all right there? Yes, Zach.
Would you say ST front?
No, because it's an actual point on here already. Okay. Good try, though. Okay, that was pretty easy. Now, what if I give you the figure and I ask for the degree of rotation now? I always gave you the degree and asked for the point. What if I give you the 2 points and ask for the degree of rotation? So there's my equilateral triangle. I want to rotate it clockwise about its center, this middle point here. What's the minimum number of degrees I have to rotate it to carry it onto itself? What do I mean by that? Carry it onto itself, so I know what I'm doing here. What's up, Sammy? Not the original figure, because that would be 360, right? But I want to get another equilateral triangle back, right? That's what I mean by carry it onto itself, is that I need an equilateral triangle back. Could I go 360? Yeah, I could, but there's something smaller than 360. I could turn this triangle and get another equilateral back. Basically, here's what I'm asking for, guys. Get to this vertice. Actually, we're going clockwise, so I should go clockwise. This vertice to that vertice. How many degrees am I going to have to rotate it? And I know a lot of people think equilateral, all the angles are the same, all the angles are 60, true, but that's only a rotation from here to here of 60 degrees. I need something a little bit bigger than that. So let's discuss. Well, first let's discuss how many times could I turn it before I get back to the original? I could do it once, right? I could do it from here to here, which would be twice. And then I could do it a third time to get back to the original triangle. So I could really rotate this 3 times and get an equilateral triangle back. And when I rotate it all the way around, how many degrees am I going? 360. And how many times did you rotate it? 3 times. So that tells me I could go 120 degrees. Okay. Or you could think of it this way. Take that center point we're rotating around, connect each vertice. Same thing. All right, that would be a 120-degree angle I rotate through. All right, so 120 degrees. What about a square? Wouldn't be 120 anymore. What could I rotate a square to get back to its original? 90, yep. Well, that's not. 90, 90, 90, back to the beginning, 90. Yep. Go ahead, Bella.
I'm so confused on like the carry it onto itself.
That means I want to rotate. Okay, there's my equilateral triangle. I want to rotate this a certain amount of degrees so I get another equilateral triangle back. Ready? There's my equilateral triangle back. How many degrees did I rotate that? 120. Okay, good. I don't know if it was originally equilateral or not, but okay. Questions? And last little, Zach?
So in general, when you're talking about degrees, if they give you, let's say they gave you clockwise, you don't have to put the negative, that's only like how many that.
Correct. Because I'm telling you clockwise, I don't need to put the negative there. If I say 120 degrees clockwise, I don't need to put negative 120. Okay? Okay, good. There you go. Right for the last slide. You missed it already. Okay, let's go. What's it going to be? For no homework. 8th period only. Star. Genie.
What's the
Clock.
Clockwise time. So it's going to be clock this time. Think about these days. Let's just quickly.
That's the thought I like, Ellie. We're not going to get it, so just let's pick something. What do we got? Promethean Man or curtains? Curtains? Okay, curtains it is, everybody. Here you go, everyone ready? Curtains or Promethean Man? Going backwards. Everyone ready? I have to mentally prepare myself. It's one of those two. Damn it! Maeve, why did you show up today? Okay, let's get through this one so you got the rest of the time for yourself. Very bitter. All those things that could come up. All right, here we go. Let's finish this off then. We're going to rotate a line now. Okay? Yesterday we did points. How about a line now? So I have the line H, which is 2x plus y equals 1. I want to rotate it 90 degrees. What's the equation of the new line? All right, so I have line H, 2x plus y equal to 1. I would like to get a visual of what this line looks like. That's why I provided the graph. Before I can do that, though, I need some help getting into y equals form. Subtract the 2x, so y equals negative 2x plus 1. Where does this graph hit the y-axis? At 1. How can I get a couple more points using the slope? Okay, all right. Up or down doesn't matter. All right, but if I go up 2, I got to go to the left one. If I go down 2, I got to go to the right one. All right. So here is my line H, and I want to rotate this 90 degrees and get the equation of the new line. I do not want to say anything else. I do not want to say this is how you do it. I'd rather you have about 5 to 7 minutes right now to discuss this within your group. I will give you one hint. A line is made up of infinite points, which can be rotated 90 degrees. And I'll leave it at that. Okay, so I will give you about 5 to 7 minutes to think about this. We'll get back to you. Okay, all right. It's a whole group number here. Here you go. Let's hear from group 8. Up front here. Okay, wide open, because there's multiple ways we could have went about this.
If you have the slope, it's going to be 90 degrees, so it's going to be perpendicular.
So the two lines, line H and line M, will be perpendicular to each other, meaning
The slope will be 1/2.
slope should be the negative reciprocal of 2. So the slope of M, I know that's weird, but the slope of M is going to be positive 1/2. Everyone else all right with that? The other way you could have done it is you could have rotated this, your paper, 90 degrees counterclockwise, pick 2 points off, new points off, put it into the slope formula, you still would have gotten 1/2. All right? What about my y-intercept of this new line?
I rotated my paper.
Okay, which point did you?
I chose -1, 0.
Okay, so you rotated 0, 1. Okay, so 0, here's what this group did. 0, 1, they rotated at 90 degrees, counterclockwise direction, and ended up where? -1, 0. Okay, that's where it goes through the x-axis. How'd you get the y-intercept?
I set it up like 0
Yep.
equals 1/2 times -1 plus b.
Yep, and your b value was
1/2.
1/2. So the equation of line M,
y equals 1/2 x plus 1/2.
y equals 1/2 x plus 1/2. Got it. Okay. Questions from you guys? Okay. I'd say start the homework, but you don't have any, so whatever else you have on you. Oh, I'm going to propose a trade. I'm telling you right now, the homework is review for the quiz. You can have no homework, or I can do no homework tomorrow on constructions. You can have the no homework now, but you are going to be skipping over reviewing for the quiz now with the homework I assigned tonight, or you can no homework tomorrow with the constructions. I'll let you vote because it'll be a majority decision here, but I'm just throwing that out there. All right. How many people want to still have no homework tonight? Okay, that made it easy then. Let's get going on the homework for tonight. Tomorrow, no construction homework, all right?